Problem 15. Zhang leaves her home and walks east for 30 meters. Then she walks north for 80 meters. Finally, she walks east again for 30 meters. How far is Zhang away from her home now in meters? Let's first get our directions right. Northeast, southwest. Okay, now let's do it. So a good thing to remember in these problems is to look at the total difference in position. And this is where it might actually help to have some physics concepts. Even though it doesn't really matter as long as you know the total position change. Yeah, the displacement as they would call it in physics. So if you just try to do it like this, it will work, but it's kind of like hard to realize that you can draw this and then turn it into a right triangle, 60, 80, and then you can get the answer of 100. That's a bit hard. So to make it easier, let's think about she went 30 to the east and then 100 north and then 30 east again. So her total eastward displacement, as they would call it, is 60 to the east. No, this is not 100 north, this is 80 north. I was thinking too much of the answer. So the total displacement, as they would call it, is 60 east, and then the total northward displacement is 80 north. So that just is an easy calculation of Pythagorean theorem. 60 east, 80 north. The total distance is, you can do this by Pythagorean triples or just calculate. So this is root of 3,600 plus 6,400, which is, so that's equal to the square root of 10,000. So that's just 100. Problem 16. And the instant you look at this problem, this is gonna seem very scary. One whole page. So let's break it down a little. The following is a 2 times 1 block. Okay. 2 times 1 block. Oh, I'm having some pen problems. This is a 2 times 1 block, and that consists of 3 vertical and 2 horizontal streets. Okay, we already know that. Alice's home is at the lower left corner, right here. And then her friend Bob lives at the upper right corner. One morning, they start together and walk to each other's home. Assume that, first, they are at a constant speed, by the way, if the problem wasn't that clear. And then, and they are the same speed, constant and the same speed. And okay, assume that both Alice and Bob stay within this block. At each intersection, Alice flips a fair coin to decide to go north or east if both directions are allowed under the assumption. If one of these 2 directions are not allowed, she will just choose the other direction without flipping a coin. Okay, so what that means is there's already a picture, but I guess we can use that one then. Or let's just use this one since we have already drawn it. So if she starts right here, then she'll flip a coin. If the coin lands heads, let's say she goes there, and the coin lands tails, she goes there. Was that what the problem says? Yeah. Okay. And then if she doesn't have a choice on where to go, if she's right there, she has to go east, then yeah, she just won't flip a coin. And then the same thing for Bob, except he goes south or west, the opposite directions, in these directions. And he flips a coin whenever he has to flip a coin to decide. And whenever he can't decide, he'll just go the only direction he can go. So it says, what's the probability that Alice and Bob meet on the way? Okay. So if they meet, then where can they be? Okay, let's simulate this. So let's suppose Alice goes there, Bob goes there, and then Alice goes there and Bob goes there. They meet right in the middle here. Okay, so let's mark that first. Okay. What if Alice goes here, Bob goes here, and then they meet right here? Okay, let's mark. I accidentally undid that one. And then similarly, what if Alice went there and Bob went there? Yeah. So they would meet at the center there. There's no other places they can meet. Like there's no other place which they're both the same distance from Alice and Bob. That's what it means. So they can only meet right there. So let's analyze each of them separately. In fact, we can do this and this at the same time because they're symmetric. So let's just look at the top one first. So Alice must go here, so that's a 1/2 probability. Bob must go there, that's 1/2 probability. And then once Alice is here, she's forced to go there. But then once Bob is here, he's not forced to go there. It's still a 1/2 chance. So let's see. Alice, it's 1/2 chance to go there. Bob, it's 1/2 times 1/2. We multiply them all together. We get 1/8. And it's the same on the bottom place to meet. It's still 1/8 because of symmetry. So how about the other meeting spot? Well, the other one, Alice will have to go there with probability 1/2. Bob will have to go there with probability 1/2. Then Alice will go up with probability 1/2. Again, same with Bob. He'll also get 1/2. So there are 4 1/2s this time. 1/2 times 1/2 times 1/2 times 1/2 equals 1/16. So we've got 2 vertices or 2 meeting spots that have a probability 1/8. When we multiply that by 2, then there's 1 meeting spot that has a probability of 1/16. So if you evaluate this, this becomes 5/16. So that is the probability that they'll meet. Okay, problem 17. ABC is an equilateral triangle with side length 1. A quarter circle is inscribed in ABC as shown. Find the area of the shaded region. Okay, when you first look at this problem, when you first look at this diagram, the really only thing that pops up to you is how strange it is. Yes, and it is really strange, but it'll be quite nice after we do some things with it. So you see a tangent, AQC. At Q, there's a tangent. What do you know when there's a tangent? Well, from the center to the tangent, it's a 90-degree angle. This is like 99% of tangent problems use this fact. It's very important. Always draw the 90-degree angle whenever you're doing a tangent problem. So this is a 60, this is a 60, this is a 60. These three sides are equal, but we'll not worry about that right now. The sides don't seem like that big of a deal right now. Until we start calculating the actual numbers, then it will come in hand. So what do you see here? If you don't see anything, that's okay. Let's make a plan first. Well, it's possible to calculate the area of equilateral triangle ABC. But then the shaded region is just ABC minus the quarter circle area. So how to find the area of a quarter circle? Well, first find its radius and do some pi things, and you'll get it. So what is the radius? The radius is this, right? It's also this. And then it's also this. Well, one thing you can see is that this line segment OR is kind of random, even though it is a radius. Where is R? Like, it's kind of hard to calculate. But OP and OQ are not as hard, and they're more significant. Like, OQ is perpendicular to AC, and then OP is perpendicular to BC. Wait. So if they're both perpendicular, can you find some right triangles in there? Yeah, definitely. This one's a right triangle. And then this one's a right triangle. And then if you see them, they're remarkably similar. They're almost the same, which makes me think if they are the same. Well, let's see. This is a 60, this is a 60, and then this is a right angle, and then there's a right angle right there also. Are they the same? Well, we've seen that two angles are the same in both of these triangles, but that doesn't mean anything yet. It means that they're similar, actually. It does mean something that they're similar, but they're not the same size. Maybe one is this, one is this. Yeah, the angles are still the same. So another thing we check is the sides. Well, we know that these two sides are the same, right? So they're congruent by AAS. So they're congruent, and let's write a few variables. How about let's let BO be X. It actually turns out there's no nasty things like radicals. So you know that this triangle and this triangle, they're congruent. So that means QC is the same as BO. So it's also X. And the thing you know about a 30, 60, 90 triangle, this is a 30, 60, 90 triangle, and OQC is also. So you know that the ratio between the hypotenuse and the smallest side is 2. So then BP is 2x. OC is 2x. So now you see something. This is BC is side length 1 because it says right here in the question. So x plus 2x equals 1. So 3x equals 1. X equals 1/3. So 1/3. And then you see there's 1/3 right here. This is 1/3. So then OQ is, you multiply √3 to that. So √3/3. So now can you see the radius of this quarter circle? So now the formula for a quarter circle area, you can just use 1/4 times pi r squared, because a quarter circle is a fourth of a circle. So 1/4 times pi times √3/3 squared is a fourth times pi times, this is 3/9, so it's 1/3. So it's equal to pi over 12. So now we have to calculate the area of the equilateral triangle. I'm not going to do it right now. There is a formula for it, and you don't need the formula actually. If you just do this 1/2, this is √3, because of 30, 60, 90 triangles, you can calculate it. So it turns out the area is √3/4. So √3/4 minus pi over 12 is what we want to find. This is just 3√3/3 times 4, which is 12. Then it's 3√3 minus pi over 12. So that's the answer. Problem 18. Define P of x equals x minus 1 times x minus 4 times x minus 9 times x minus 16. How many integers n are there such that P of n is less than or equal to 0? So we see that P of x is defined in the factored form, which is easier. So let's see how we can make it less than or equal to 0. First, equal to 0. So if it's equal to 0, then x either has to be 1, 4, 9, or 16. And then if it's less than 0, let's see. If each of these factors is positive, can we make it less than 0? No. If 3 of them are positive and 1 of them is negative, is it less than 0? Yes. So let's write that down. And then if 2 of them are positive and 2 of them are negative, is it less than 0? No, it's not. And if 1 of them is positive and 3 of them is negative, is it less than 0? Well, yes. And then if all of them are negative, no, it's greater than 0. So we have these two cases to consider other than 1, 4, 9, and 16. So how are 3 of them positive and 1 of them negative? Let's see. If x is less than 1, all of them are negative, right? if x is between 1 and 4, then 3 of them are negative and 1 of them is positive. Well, that's what we want, so we can add those two cases, 2 and 3, in there. So 1, 4, 9, 16, there's 2 and 3. And then if x is between 9 and 4, then there are 2 negatives and 2 positives, so that won't work. And then if x is between 9 and 16, then there are 3 positives and 1 negative, so it works. So let's get them in: 10, 11, 12, 13, 14, and 15. And then if x is greater than 16, then all of them are positive. That won't work. So it's just these solutions. There's 4 here, there's 2 more, and then there's 6 more. So 4 plus 2 plus 6, there's 12 solutions. Problem 19. The 6 pairwise sums of 4 distinct numbers in no particular order are 39, 64, 77, 92, A, and B. Find the smallest possible value of A plus B. Okay, so let's set some variables for the 4 numbers. Suppose they are W, X, Y, and Z. So then, what do we want? A and B, we want them to be the smallest. So how about this? Let's first order W, X, Y, and Z. So it doesn't really matter how we assign the variables. So let's make W less than X, which is less than Y, which is less than Z. Then W plus X is the smallest sum because it has the smallest numbers in it. Then next comes W plus Y. And then we can also see that the biggest sum is Y plus Z, and the second biggest is X plus Z. Now the third and fourth smallest, it's not apparent if it's X plus Y or W plus Z. So let's just let it be. Yeah, we don't need to care about that actually. So Y. So to make A and B the smallest, let's assign A to be W plus X and assign B to be W plus Y to make them small. And then let's just do this. 77 and then 92. So we have these equations. But what are 39 and 64 equal to? Well, they're either equal to X, W plus Z, or X plus Y. And then this is either X plus Y or W plus Z, but it has to be different from 39. So how do we find A plus B? So let's find A and then find B. So A is equal to W plus X. But how do we get W plus X? Well, let's add a Y plus Z on there. So A plus 92, this 92, equals W plus X plus Y plus Z. Why do we do that? Well, you'll see later. And then, what happens when we add 39 and 64? 39 plus 64 equals. Well, 39 is either W plus Z or x plus y, and 64 is either x plus y or w plus z. So if you add them up, you'll get w plus x plus y plus z in either case. So a plus 92 is equal to 39 plus 64. Now, do the same thing for b, except this time to make w plus x plus y plus z, you have to add 77. That makes w plus x plus y plus z. And then that's equal to 39 plus 64. So now we can calculate a and b. A is equal to 39 plus 64 minus 92. So 39 plus 64 is 103. Then minus 92 is 11. A equals 11. And then B is equal to 39 plus 64 minus 77. So this is 103 again. 103 minus 77 is equal to 26. So A plus B equals 37. Problem 20. N is a two-digit even number. If the last two digits of n squared is the same as n, what is the sum of digits of n? So n and n squared both end in the same two digits. So what happens if you subtract n from n squared? The result will have 0, 0 as its last two digits. So it must be divisible by 100, or you can write it in this way, equal to 0 mod 100. So let's factor this. N minus 1 times n is equal to 0 mod 100. So 100 is equal to 4 times 25 is equal to 2 squared times 5 squared. So let's analyze the 5 part first because it's more restricted. So n and n minus 1 have to multiply to a number that's divisible by 25. So that either happens when it's 1 and 25, so n minus 1 is divisible by 25. Let's write that down. Or n is divisible by 5 and n minus 1 is divisible by 5. Wait a minute. Do you see something wrong in this? N and n minus 1 can't be both divisible by 5, so we'll rule that out. And then n is divisible by 25, n minus 1 is just any integer. So that's also a possibility. N is equal to 0 mod 25. So there are only a few values that can work. It's either 25, 50, or 75. Let's just look at all the cases. N is equal to 25. Nope. N has to be even, it says. N minus 1 is equal to 25. That's possible. Then n would be equal to 26. If n was equal to 50, that's another possibility. If n minus 1 was equal to 50, then n would be odd. If n was equal to 75, n would be odd. If n minus 1 was equal to 75, n would be 76. So those are the only possibilities. Let's check each of them. So 26 squared minus 26 is equal to 26 times 26 minus 1 equal to 26 times 25, which is equal to 13 times 25 times 2, which is 50. I just moved the 2 from the 26 into the 25, making it 50. This doesn't work. Nope. Okay. So let's try 50. Well, 50 squared is 2,500, and 2,500 definitely does not end in 50. Then 76, this should be correct now. 76 squared minus 76 is equal to 76 times 76 minus 1, factor it, 76 times 75 equals 76 is 19 times 4. And then 75 is 25 times 3. So we see there's a 100 here. So that's equal to 19 times 3 times 100. Yeah, so that's it. 76 is the right answer. So 7 plus 6 equals 13. And we are done. Thank you for listening to this, and I hope you have a good day. Bye.